All right, now we're going to continue our review for the next lecture exam, and we're going to be talking about Newton's second and third laws of motion. So in our previous segments, we've talked about Newton's first law of motion. Now we want to do Newton's second and third laws. So you'll notice that you want to finish up Chapter 2 in your textbook, and then do Chapter 4, and then also do Chapter 5. So this is a review, and you should now understand what acceleration A is, and you should know what it does. So when something's accelerating, it makes your speed change. You should also understand what mass is. So mass is the same thing as inertia, and the more massive an object is, the harder it's going to be to get it to move, and then also the harder it's going to be to stop it from moving once it is moving. And then we also talked about what force is. So a force is a push or a pull, and we found out that forces can change the speed of an object. Another name for that is forces cause objects to accelerate. A force can also change the direction that an object is moving, and then a force can change the shape of an object. And then we also did Newton's first law of motion, which says that an object that is moving will continue to move forever and ever at a constant speed unless a force acts on it. And then if an object is not moving, it will continue not to move forever and ever unless a force acts on it. So that's a review of what you should know already. So now we're ready for Newton's second law of motion. So we're going to say that a force causes a mass to accelerate. So that was his second law of motion. And notice it says the word total. So what that means is if you've got more than one force acting on a system, add the forces together. So the total force acting on a system is what's going to cause that mass of that system to accelerate. So I wanted you to notice what happens if there's no force. So if there is no force acting on the system, then F would be equal to 0. And then you would have ma. Okay, and then notice that you could divide both sides by m. And so 0 divided by m is going to be 0. And so now you've got 0 is equal to a. What does that mean? 0 acceleration means it's moving at a constant speed, because this thing here is going to be v final minus v initial over t. That's the definition of acceleration. Then you can take the t, multiply it by 0, which is going to be 0. And now you've got 0 is equal to this thing here, v final minus v initial. Take a v over to the other side, and you end up with that the final speed of an object is equal to its initial speed. And that is exactly what his first law says. If there's no force acting on a system, then it's either going to just sit there, or if it's moving, whatever its initial speed is, it's going to have that speed forever and ever. So notice that his first law is built into his second law of motion. So definitely going to be a test question where I'm going to give you 2 of the 3 letters, and then you have to plug it into the formula. So in this particular one, if a force of 10 newtons acts on a 5 kilogram box what will the box do? So you're going to plug those numbers into force equals ma. You end up with an acceleration of 2 meters per second squared. So the box is going to accelerate. Its speed is going to begin to change as a result of that force. Okay, another thing I'd like you to realize is if we go back to this one, where we said that the more massive the object, the harder it was going to be to get it to move, and then the harder it was going to be to stop it from moving. Well, that is, if we go back to here, in this statement. So if force equals ma, if you have a very massive object, so if the m gets bigger, then what happens is the a will get smaller in order to compensate. So think about 2 times 2 equals 4, but 4 times 1 equals 4. So if this one gets bigger, this one gets smaller in order to compensate. So if you've got a very large object and you apply a force to it, it's not going to want to move very much. On the other hand, if it's like a ping pong ball and the m is very, very small, then it's going to have a large acceleration that goes with it. So this idea of inertia is again inside of this formula, the second law of motion. Okay, next thing, well, let's take a break. So when we come back, let's talk about what's the difference between a vector and a scalar.